Hi class, I just wanted to put together a quick video on the seasonality video we discussed last night. Before I do so, I want to apologize for any confusion I might have caused you. I was just going through my notes and I realized that the confusion on my end, believe it or not, stemmed from the fact that I couldn't tell the difference between decimal points and the multiplication symbol on my notes. So I'm really sorry for the confusion, and I hope that this video will clear any confusion up for you. Before we jump into the problem though, I'm just going to do a quick recap on how the seasonal indexes converts seasonal data into deseasonalized data and vice versa. I really liked how one of your classmates used the metaphor of the indexes being a key. And I think that's a great way of visually describing how this all fits together. As I said in a previous video, for the scope of this course, you're only required to know how to apply indexes to data using the multiplicative model. So I'm just going to draw out a quick short graph to show a data set showing the deseasonalized data. And because we are working with stable data, the data set will always be constant. In this case, we have 4 seasons, and each season represents an average sale of $10. And now I'm just going to quickly write out an arbitrary seasonal index. One type of problem you might see would be something like using the following index, convert the following deseasonalized forecast into a seasonalized forecast. To visually show you how this works, let me quickly draw out another graph where we will be plotting our seasonal data. And now we're ready to use the index to convert the deseasonalized data. So starting period 1, which has a value of 10, we go to the index and we find period 1. And we see that has an index of 1.2. So we multiply the value, which is 10, by 1.2. 1.2 times 10 is 12, so we can plot our new value here at 12. And now we do the same for the rest of the seasons. So period 2 has a value of 10 and an index C of 0.3. 10 times 0.3 is 3, so we can plot that here. Period 3 again has a value of 10, and as we see here, has an index of 0.6. 0.6 times 10 is 6, and we can plot that here. And finally, season 4, value of 10, index of 1.9, that gives us 19, so we can plot that right here. And with that, we can see how we use the index to convert the stable deseasonalized forecast into a forecast that has included the seasonality. So you'll be given a seasonalized data and an index and be asked to convert that to a deseasonalized data. So let me just set up the seasonalized graph again and our index, and we're ready to go. So in this case, we get the value for season 1, which is 12. And instead of multiplying like we did last time, we divide 12 by 1.2. because we are taking seasonality out of the data. And we'll plot that right here with a value of 10. And now we just repeat with the rest of the seasons. So season 2 has a value of 3. 3 divided by 0.3 gives us 10. Season 3 has a value of 6 divided by 0.6, once again, gives us 10. And then season 4 has a value of 19 divided by 1.9. Surprise, surprise, we get a 10. Another point I like to make about the seasonal index that I think will clear up these numbers is that the values represents a percent increase or decrease from the average. So for example, here 1.2 means a 120% increase over the average, as in this case. And then the index of 0.3 means a 30% decrease average, as in this case. So I hope this clears up how deseasonalized data, seasonalized data are related with the seasonal index. And with that, Let's take another look at this problem again. Okay, so let's start solving this problem. First thing I'm going to do is start forming our table. So here we have season 1, 2, 3, and 4. And we are given sales of 100, 30, 50, 20. Now again, looking at the directions in the other video, the first step you do is you compute the seasonal average. And in this case, we're actually given the seasonal average. We're saying that for the early season of early AM, we have average sales of 100. For season of late AM, we have average sales of 30. For season early PM, we have average sales of 50. For late PM, we have average sales of 20. So in this case, we are given step 1. Step 2 of the direction tells us to compute the overall average. And so in order to do that, we merely add these numbers together, which gives us 200 divided by 4, and that equals 50. So step 2 of the direction is 50. The next thing we do is we create our index by taking step 1 and dividing it by step 2. So let's do that. 100 divided by 50 gives us 2. 30 divided by 50 gives us 0.6. 50 divided by 50 equals 1. 20 divided by 50 equals 0.4. And now we have our index. All right, so now let's look at the last part of the problem. It says that the overall demand is lower in January, but the seasonal indices holds the same. So the index remains the same. And so let me just write this out. We know that we will still have the 4 seasons. And in this case, we sold an average of $80 in the early AM shift. So let me put $80 here. And the question asks us, how many would you think we might sell in the next shift? So basically, we need to solve for this. But for the purpose of this demonstration, I will solve for season 2, 3, and 4. First of all, like previously, we need to realize that the $80 in sales, like the previous $100 of sales, represents seasonal data. So the first thing we need to do is, by using the index that we just created, we need to figure out the deseasonalized data for season 1. Once again, when we go from seasonalized data to deseasonalized data, it means that we're going to be dividing. So this time it means season 1, which is 80, divided by the index of 2, which gives us 40. $40 of unseasonalized sales. And now that we know that the deseasonalized average sale for the first season is 40, we know that the deseasonalized average sale for the rest of the seasons are 40 as well, because once again, we've taken the seasonality out of the data. Now that we have the 40, we need to include seasonality back into our forecast. So this time we'll be going this way. And when you go from deseasonalize data to seasonalize data, we multiply. So 40 times 0.6, and I need to start using periods for multiplication because I obviously get confused. So 0.6 times 40 gives us 24. 40 times 1 gives us 40. And then 40 times the index of 0.4 for season 4 gives us 16. And so what we essentially did with this part of the question is we were given seasonalized data. We use the index to deseasonalize the data. And because this is deseasonalized, we know that the rest of the seasons have the same value. Because once again, I want to reiterate, we're only dealing with stable forecasts. And through this step, we know that the deseasonalized value for each season is 40. And now we can multiply the values of the index into the deseasonalized value to give us the seasonal value for each season. So I hope that this video has clarified any of the questions that you had last night.